Okay, so here we go. We're here with the team from LuxWall. I'm very excited for this one. Generally speaking, in the market, VIG is a very hot topic and something that I think everybody will be very interested in. So this is going to be a learning opportunity for everybody. And so thank you guys for joining. And I want to give each of you, maybe for Scott, Leanne, and then Jake, a minute to introduce yourself.
I am Scott Thomsen, founder of LuxWall. Been in the glass industry for many years, all at Guardian Industries, and really just started LuxWall to commercialize VIG on a mass scale.
And I think everybody, we should preface just for the audience, LuxWall is being produced out of where?
Out of Litchfield, Michigan.
Awesome.
So I'm Leigh Mays. I've been in the glass and glazing industry about 13 years now, also from Guardian Industries originally. And I've always been in the Northeast working with, different glazers and architects, for large scale projects across the Northeast.
I'm Jacob Kasbrick. I've also worked at Guardian Glass. I've been in the glass industry for about 13 years, calling on architects, glazers from coast to coast, and dabbling in product development and other facets. So fascinated by the opportunity to come to a company that has a great VIG product to help out with thermal performance.
Awesome. Very exciting. So I think it'll help to dive into a little bit of the history around VIG, because I think what's a little bit of a misperception in the market is that this is new technology. And although we do have new materials and means of fabricating and assembling the units, the concept of VIG is not new. So Scott, I think it'll be interesting if you touch a little bit on the history, certain aspects of the market where it was applicable, and maybe lessons learned on things that did and did not work in the past, and why we're here where we are today.
Okay, that's a great point, Adrian. The original concept of vacuum between two lights can be traced back as far as the 1950s. Okay, so yeah, it is not a new concept. Okay, it's been around, 70, 80 years. Okay, and then the first kind of major work was Professor Richard Collins at the University of Sydney, who in 1990-ish time frame really is the pioneer of modern vacuum insulated glass. And so between 1990 and really 2000, he did a lot of groundbreaking work on, perimeter seals and, vacuum lifetime, and, really did a lot. And he held the core patents on a traditional VIG, what you exist today. And so several Asian manufacturers that produce today produced to Professor Collins' process. With some improvements, they took a license from the University of Sydney, and that was really the birth of vacuum insulated glass, came out of Australia. Okay. And then, there's really been, what I call regional production or regional attempts at VIG. You had a few people in Europe that tried back in the late 90s, 2000s. Even the German government had ProVig, which they sponsored a large program to try to produce VIG. Okay. And then you've had various startups in the United States over the last 20 years that were primarily funded by the Department of Energy. And then you've had, probably as at any point 10 to 12 companies in South Korea or China or other parts of Asia that have worked on VIG. Okay.
So I'm going to interject and ask where was this push for VIG? A little bit of the history around the transition from monolithic to insulated assemblies, and then where VIG plays into that history or trajectory.
Yeah, no, that's a great question, because I think when you look at, the advent of low-E coatings is a good example, because for years you had pyrolytic, and you got, limited solar heat gain. You might get the solar heat gain down into the 0.55 to 0.6 range, where, clear glass is 0.84 in that range. So, pyrolytic gave you some improvement in U factor, and it also gave you some improvement in the solar heat gain. But it really wasn't until, the double silver low-E coating where you really drop the U factor and you really drop the solar heat gain down into the 0.27 to 0.37 range. So Professor Collins, who really was looking at it, he was thinking, what comes after, a double pane argon with low E, which today is like a center of glass R4. So he was kind of saying, okay, yeah, we've gone from pyrolytic to sputtered. What is after? And I think that's what most people were chasing was, is there a way to get to triple glaze performance in a form factor that is equal to a double glaze or less? I think
so insulated units with roughly an R4 were commonplace even before the VIG concept or discussion was coming to play.
Yeah. The concept had been, it's interesting because back in 1990, it was kind of when that sputtered coating, so they kind of both started at the same time. And then people had already proven in the late 80s that you could hit that performance. It wasn't mass scale, but, from a scientific point of view, so it was more, why work on another incremental, kind of evolution? Let's work on something that's more of a step change.
And so at that time, instead of just progressing towards triple glazing and making that the norm, things concern about embodied carbon with introducing a third pane of glass, or the worry about the durability of a second perimeter seal. Were they thinking in that sense as to let's avoid the triple route and go this other route?
I mean, I don't even think people knew what embodied carbon meant in the 90s. You know what I mean? I don't think that was people would be, what's wrong with you? So yeah, I think, that was there. I think what happened is people could make triple glaze by running the IG through their line a second time. So really no incremental capital. And the demand at the time was so small that you could use existing assets versus going out and buying a whole new dedicated line to make an unproven product in the market. It's the risk was so much less to go to triple than it was to go to VIG.
So at that time in the 90s, did they really think there was a place for it in the market? What really drove that? I mean, today you have new energy codes and sort of this climate crisis where we're trying to get to net zero. And I think that's going to really be an instigator or an accelerator for something like this. But why was it even a discussion point in the 90s?
I think that's why it was mainly focused at university level, because, that's what universities are funded to work on, things that are 10, 15, 20 years out. So, and I think, a big part of it, Professor Collins had an intense passion for vacuum insulated glass. So if you have a person that's got a lot of passion and they're very smart, like he is, he was going to be the pioneer of, the next generation of glazing. I think that was probably the primary driver, was, what's next? Because, you look at it, it is such a deviation from how units are traditionally made today that, it's going to take time to work the bugs out and understand all the failure modes and to come up with a set of materials, a product, and a process that can get a low cost of goods sold.
So that's almost 30 years ago. What do you think, I'd say, went wrong, or what are some of the lessons that we can recap from then, and why is it coming up as a discussion point today? What was sort of the evolution in the 2000s and 2010s?
I think what happened was, I think once people started to embark on it, they realized it was a lot harder than it seemed. Okay, because the biggest challenge is, argon has a certain molecular weight, and so if you have like a stainless steel box spacer with hot melt butyl or polyisobutylene as your primary seal, and then silicone or polysulfide as your second seal, you can contain the argon in the cavity. Okay, and we all know there's some seepage over time, but you're going to maintain it. Well, in vacuum insulated glass, if you're, say, R12 center of glass, if you get a leak or a defect, you go to 2. So it's catastrophic failure. So the seal has to be hermetic. It has to last 20 years. And that's the challenge, is how do you come up with a seal that lasts 20 years? And the easiest way to do that is to use what I call a high temperature solder glass. Well, the problem is, if you have a high temperature solder glass, you detemper the glass. And so that's why NSG was very successful in Japan, because they don't have the same tempered laws and other safety glass laws that you do in, say, the US and Europe. Okay. And so they were doing a 5-6 millimeter monolithic replacement, but an annealed only product was suitable in the market.
Interesting. So they didn't run into issues with thermal stress, having an annealed light without being heat strengthened or tempered?
Well, yeah, because you see, but they didn't have high performance low-E's on it with, if you put pyrolytic in there, you're not getting that absorption into the glass that leads to thermal breakage. And this was another challenge to overcome. So now you got to overcome the challenge of how do you not detemper the glass and be hermetic and can do a 20-year warranty. Now you need a coating that can survive a high temperature process. So if you have like a double or a triple silver low E, they're sensitive to time temperature. So what happens is now all of a sudden it becomes the challenge. You got to come up with a process that doesn't detemper and doesn't destroy sputtered coatings. So that becomes kind of the second hurdle. So people struggle then, you can't detemper the glass, and now you got to be able to produce it with a very sensitive, double sputtered, double and triple silver low E. So it's kind of like peeling the layers of an onion. You think you understand it at this point, and then obviously you get one layer down and realize you don't know what you don't know.
My mind is a little bit blown right now. I'm trying to absorb all of this, and I'm going to have to go back and rewatch about 5 times. So I hope everybody's enjoying this so far. Before we dive back into the fabrication of the assemblies, and maybe Leanne and Jake can start chiming in here, I want to touch on the performance around VIG units, and we can discuss standalone units versus insulated units, but from a designer standpoint, what they should be thinking about in terms of what they would typically specify in a building versus what they can now achieve. And areas I want to focus on are thermal, obviously, but then acoustics, because I think that's an area that there's a lot of unknowns around.
I think vacuum is really interesting these days because everyone has an extreme interest because of the massive change in energy code requirements. When I first started working in the glass industry, a basic unit, not even with argon, was readily available and it was commonplace in what was specified. And that was 2010. So here we are like 13 years later, and the market in Boston's all triple glazed and still struggling to hit some of the energy code requirements, even with triple glazed units. And so people are looking for alternatives as to what to do. I can even remember back when I worked on my first triple glazed job, like everyone was shocked because of cost, implication to the metal system, and now it's much more commonplace. And so like when I'm talking to architects and owners about vacuum insulated glass, their first questions to me is, what does it perform against a triple glaze? Because triple glazed is now like the benchmark for baseline performance, especially in the Northeast. So I think it's interesting. And the way I talk to them is we're using a lot of the same low E coatings that they're designing with today. Really, the only difference for us is the thickness of the overall unit, along with what we're doing in lieu of a traditional argon-filled airspace, right? We're just pulling a vacuum. So it's similar to what they're designing with today, same low E's. We can adjust solar heat gains. We can work with you on the different aesthetics, but we're providing a far better thermal comfort for the interior occupants on a cold winter day in Boston.
So when you start looking around the country, and as Leanne mentions, the code starting to change in that triple glazed market in Boston, but you look over in Canada, it's always been a triple glazed looking for a solution that's more cost effective. But you have different cities popping up where their code's starting to go down. So I live in Nashville, and we're starting to see a little bit more argon filled, which historically was clear over clear with a very baseline low E. But when you start looking at New York City with the local law 97 and the carbonization taxes, and you start looking at the boilers and the lighting, you're going to have to look at the facade, and it's a big overtaking and a lot of money to disrupt an occupant, go in there and take something out, and you're going to put something in there that's really not going to give the same performance as that boiler upgrade. So when you start looking at the thermal performance of VIG, it starts making those upgrades more viable, and it does upgrade the building and as a viable solution. So when you start talking about thermal and solar heat gain that Leanne mentioned, you do get those acoustic values that you were asking about. So when you look at a center of glass 1-inch IGU, you're roughly about a 35 STC. An 8mm in thermal VIG unit's going to be an STC of 35. We could do a mate light and make it into a 1-inch, roughly 25 millimeters, and we're going to be a center of glass right around a 39, which is similar to an 1 5/16 unit with a lamination. So when you start going around and talking about buildings in Nashville per se, it's the healthcare hub of the United States. A lot of medical buildings are very conscious about that acoustical comfort, which it's a lot of money to put lamination in there. So this does offer a solution there. And when you start looking at about all these offices with vacancy rates around the country, and a lot of people working from home, multifamily is a booming environment. This is a perfect way to have a product, even in southern states, where at nighttime you're 90%, 100% at capacity with occupants, their HVAC systems going full speed. Now we have a product when the sun's not out there and you don't need that solar heat gain blocking. You have something that's going to keep your energy costs lower. So you could see multiple segments in how this plays outside of just talking about thermal performance.
Yeah, I mean, I think in certain markets you're more challenged than others. I will say you do see markets like Boston, New York, Seattle leading the charge with progressive energy codes, and it's really made its way down from Canada, and now it's bleeding into the lower climate zones in the US. I'll say in a market like New York, where you're dealing with acoustic requirements by OER, bird-friendly glass, and then thermal requirements, marrying those three together is an incredible challenge. So another kind of talking point and something I'm curious how your outlook is on this. When we do window replacement, especially, you can put a well-performing window and frame in place, but if your adjacent surrounding opaque wall is not well insulated, you run into condensation issues. So immediately you'll have designers asking, well, is your limestone or adjacent brick insulated? So from your standpoint, if you think about retrofitting a VIG into an existing window frame, it's kind of like putting a super performer in terms of the glass within that frame. But if you have existing framing that's not thermally broken, could you run into condensation issues, especially if you have such a delta between the glass and the frame itself?
No, Adrian, yeah, that's a great point because, so a lot of times people in the past said it makes no sense to take VIG and put it into a non-thermally broken frame. But, Jake and Leanne both are working projects right now where the budget doesn't afford taking out the frames. The frames are in good shape and you can go in and replace the glass. So we're doing, a lot of right now condensation resistance testing because, it does depend upon the geographic location, what is your climatic conditions, how many dew point transitions do you have? Okay, and the whole thing is the condensation going to be on the inside? Is it going to be on the outside? And then will it burn off by 9 in the morning, 10 in the morning, 1 in the afternoon? So I think, in general, it is very site specific because, I think it's part of the evaluation process you have to make, exactly what you brought up, because you can have a metal frame, but if the walls are well insulated and you put this in, okay, it's going to be a different story. The worst case is a brick building, a non-thermally broken frame, the frame sitting on the brick. Yeah, you're going to have a higher probability of a condensation in that situation.
Yep. Interesting. So before we go on to the fabrication process, one other topic I want to touch on, and this is a significant unknown to me and a question I get a lot. Do you see a future where we will see the marriage of bird-friendly glazing and VIG?
I get
Yeah.
asked every day about bird friendly. Almost every single project I go into, because of the requirements in New York, and it's even actually bleeding into Boston, which I was shocked about, because there is no law, there is no requirement. However, I was on a call the other day where a building is having issues with birds, and then they're reglazing it and they're redoing the existing facade. So we're having the conversation of, well, what does it look like? And I think it depends on what you're trying to achieve, because we can incorporate either from a thermal hybrid option where we're using some of the UV coatings, or we could work on, doing some sort of acid etched appearance. It just depends on what you're looking for. I'll let Scott touch a little bit on, some of the other things we're doing from a bird friendly perspective, but we have solutions and we talk about it no different than what you guys are talking about, now. It's like, well, how much do you want to see of it? And how do you want to incorporate it? And how aggressive do you want to be on your threat factor?
So to Scott, before you answer, I know with bird friendly that the deterrent has to be in front of the low E coating. So in that case, if you were to use a UV interlayer, I'm guessing the laminated light would be outboard, and then you'd have your VIG inboard. And to that same token, for an insulated unit, will you just put your frit pattern on the number 1 surface and deal with the VIG inboard?
Yeah, you could do that. So you could do the lamination. When you're going to do that with the UV coating, you want to have the UV on the number 1 surface. As soon as it goes on the second surface, you start to have 7% reflectivity. The efficacy goes down. You do need to have on most of the UVs that have the lamination right behind it to add that contrast. So for that, you would have the Lamy outboard light with the VIG unit on the inboard. Now, the hybrid unit that Leanne was talking about, we'd have the sacrificial light on the outboard, 6mm. You could put the frit pattern. There's a few manufacturers that can do frit on the number 1 surface. Now, we will have a low E coating in our VIG unit. So hypothetically, you can get away with just using the frit number 1 and would not have to put a low E coating on the second surface unless you needed to have extra energy costs or you wanted to have a certain aesthetic from that low E coating. But that does give you an option to get the performance with the frit number 1. Because again, it's true when you put the frit on the second surface, that efficacy does drop. Now, there's another option where you can have an etching process where you can do it on the hybrid unit, but it is also unique. We could use that on an in-thermal unit by itself as well. So we can hit every single option that's out there in a traditional standard just using VIG right now too.
Got it. Okay, so let's move on to durability and fabrication. And now I'm really going to challenge Scott. So I want to hear about how you are addressing assembly of these units and concerns that might come up around, well, what happens if that hermetic seal fails? Or what happens if we don't have a durable perimeter edge seal? How long is that unit going to last? And how are these units being assembled today to mitigate that risk?
I mean, that's the $10,000 question, because so when you look back historically, what I mentioned before, people used high temperature sealing glasses, which, detempered the glass. Okay. So as you lower the melting point of these perimeter seal materials, you become more susceptible to moisture, vapor transmission, water migration through the seal. The density of the seals goes down in grams per centimeter cubed, and so as the density drops, the cohesive strength of it drops. So that's the biggest challenge, is you've got to lower the melting point so that you can, not detemper the glass, but then you got to maintain this hermeticity, and then you've also got to maintain moisture resistance, and then also mechanical durability. Okay, so that's where we put all our effort for 3.5 years, was on that perimeter seal. Because if you can't solve that problem, then then you're never going to get to a 20-year. And so
thinking about, how do you think about life cycle testing or sort of accelerated weathering testing just to ensure the effectiveness?
Yeah, so we have a very large lab with a lot of environmental chambers. Okay, and I'll give you an example. So like for thermal cycling, in a traditional IG, 2188, 2189, and 2190, the ASTM standards, you cycle between minus 30C and, depending upon your level, 65C. Okay, well, what we do is we cycle from minus 70C to plus 130 C. Okay, and we do it in 4 hours. Okay, so we're doing a bigger range, and we're doing it 2 to 3 times faster than the test standard. Okay, and then we do it for an extended duration. Okay, and then what we've done a lot of is combinatorial testing, where we actually soak our entire unit in 65C DI water for 10 days, take it out, put it in this -60, -70 to 130 thermal cycling, take it out, same unit, we put it in 85C, 85% humidity. And then we take it out and we do plus and minus 90 degrees C asymmetric thermal shock, where the inside of the chamber is -70, the outside is 20 C. And then we'll take the inside of the chamber up to 110 degrees C, and then the outside is 20. So like that's a test regimen for us, because the problem, and this is, and you can go to the ASTM committees, Adrian, on VIG. Our product will always pass 2188, 2189, and 2190 because they were designed for organic sealants. Okay, we've never failed. Okay, so the problem is, and the ASTM committees, along with NREL and LBNL, they know they need to come up with tougher standards for VIG, and that's why there's working committees and working groups. You know, we got to, as an industry, we have to come up with much tougher standards to make sure inferior product does not get into the market and then tarnishes the vacuum insulated glass name. And I'll take one other thing, and I don't want to get too much into this because we do consider it, you know, a little proprietary, is we've also developed special chambers to simulate 20-year life. And we have an extreme cold situation and an extreme hot situation. So it's a very complicated test, and it's based on accelerated test theory, but we have to prove to ourselves because we are offering a 20-year warranty.
Wow, that's what I was going to ask. So
Yeah.
What I take from that is accelerated and extreme thermal testing to ensure that the effectiveness of the perimeter seal. But really, in my head, I was thinking about center of glass deflection under extreme wind loads.
Okay, and that's another thing. So we've been doing a lot of wind load testing, okay, in customer frames, okay, at Intertech and Element, okay, and then, but we've also done a lot of finite element modeling analysis. So we look at both wind load by itself, we look at thermal deflection by itself, and then we do a combination of wind load and thermal at the same time. Because when you get to bigger units, the deflection will be 19 millimeters, which is 3/4 of an inch. Okay, and this gets back to, this is why you have to be tempered, or for sure heat strengthened for vacuum insulated glass. Otherwise, you're going to be limited in the sizes you can make.
So what is the largest size we're talking about?
Well,
roughly.
Right now we can go up to 60 by 96 on a 2 light and thermal. Now, I will say, Adrian, we do increase the thickness of the glass, just like a regular IG, because, you know, when you guys do big curtain walls, you might go from 6 to 8 to 10 millimeter glass. Okay.
Sure. Well, in my head, I'm thinking anywhere above roughly that size, we'll have to think about thicker light just to achieve that 1 inch center of glass deflection, whatever that criteria is.
Well, and we're trying to stay below 18 millimeter deflection max. Okay.
So,
and so
do you have to consider or think about in a window or curtain wall system that either is mechanically retained, or it doesn't matter if it's captured or the glass is exposed and it's structurally glazed?
Well, makes a huge difference. You know, the bite makes a huge difference. And like, we'll take 2 frames and they look very similar. They don't test the same because the bite matters. You know, how the gaskets, whether it's a zipper gasket or a retention gasket, that makes a difference. And then how much slop or how loose, you know, the glass is in the pocket. All impact. And so we do all our modeling. We then go do the testing. We've correlated the testing to the model, and then we put a safety factor on the glass thickness to the size. And the other problem is the aspect ratio makes a difference. You know, if it's, you know, short and tall, or narrow and high, or versus a 1-to-1, that also impacts, what glass thickness you need.
Now that we touch on a lot as it comes to performance and durability, I want to get to aesthetics a bit. So, I've seen a 12 by 12 sample, but when we're talking about job specific sizes, especially larger units, and you have a scrutinous team on the project, what has the experience been, and how do you see the implementation in terms of having project specific visual mock-ups and any disparities that one should be aware of when you're looking at a small 12 by 12 sample, and then when you start to get to job specific sizes?
Jake or Leanne, you can take the.
Yeah.
You're in the field.
Yeah, I was like, I think it depends on the person. Some people scrutinize the sample far more than others. And then sometimes I find myself pointing out the pillars that keep the glass from touching when we pull the vacuum because they haven't even noticed them. And then there's other people that immediately see them. But then once you hold a sample at a distance and you start to have that conversation of you're never going to be on top of the glass, or when it's on a building, you're looking through the glass to like the outside, whether it's a green space, another building, that kind of visual noise distracts from your pillar identification. But, I very rarely get pushbacks on the aesthetics. Most people, the only concern that they do tend to have is around the cap on our port where we pull the vacuum. But it's very small and it stays the same size, whether it is, a small sample or all the way up to 5 by 8. The port cap size does not change.
And I've heard you make comments to me about, being intentional about placement of that cap, whether it's in the top corner of the window or somewhere that might be under window treatments and not really exposed.
Yep, that's exactly correct. And also on the pillar spacing, I have had similar comments. It's really not brought up. Most of the time I have to point out that the pillars are there, which is a really testament what Scott's been able to do with the product. But if you think about any airport that's out there right now, they don't have overhangs, they don't have shades going down. So what's typically used on those? 1/8 inch, 16th inch dot patterns. And when you're 5 feet away, you can see it. 10, 15 feet away, it looks like transparent glass. So the human eye has already been accustomed to seeing bigger dots on glass and really not bat an eye in the application. So when we have a pillar that's as minuscule as it is, it's really just understanding where we have the cap placement. And then we get into the normal conversation of the Leigh coating and get into the aesthetic as if we would in a 1-inch IGU.
Yeah. And what's interesting, Adrian, what my experience is that the cap is a bigger problem on the sample than it is on a big unit, because when you have a 14 by 20 sample, the cap looks like it's a big percentage of the sample. When you get it in a 5 by 8, it's really not there.
Same thing with a window frame. If we do a corner sample with a little 12 by 12 piece of glass, what's with these, big fat 3-inch sight lines? And I'm like, when you see that in a 5 by 8 window, it's nothing.
That's right.
Yeah, exactly. It's the same. So it's sometimes it's worse with the sales sample.
Yep. Okay, so in terms of market segments and where you see opportunity, I'm an existing building guy just because I'm obviously from New York and I'm in Boston a lot, and these are really prime markets where you have building owners that pay honus to and are willing to really reinvest in their assets. What excites you more, and what are sort of unique and different challenges in the existing building versus new construction markets?
In the existing building, I was actually talking to an owner in Michigan, and he had a 10-story office building that was sitting vacant, and he wants to turn it into a more lively city. And he's like, we need more multifamily. So he was looking at our product and get on a call with him. And we start talking about the R value. He's very impressed with it. Happy to hear he can use a domestic low-E. When I told him that he can keep the metal in there, his mind was absolutely blown away. So it's going out there and educating them that you can keep that historic look. A lot of these buildings have the historic society behind them as well. So they're heavily scrutinizing the products. And we have those organizations really behind us and are advocates for our product for the thin profile, not changing the aesthetic of the original building. So that's a big thing, is educating people to retrain how they look at a facade. Is, hey, you can go in there and keep the existing system, see how it performs with ours, and you can do a cost analysis against a new construction where you take all the metal out, you have the cleanup, the abatement team going in there, all that time and money, where we can really help the timing of a schedule for a project to move forward and give them superior performance. So that's been a big thing, is educating that segment on how we can be a solution to their facade.
Yeah, I think it really comes down to now VIG gives people more flexibility in their overall design, right? So historically, if you had a facade that couldn't change out anything because of its historic nature, or it didn't have the structural load capacity to carry what, modern day metal and glass weight would be, you now have a solution to reglaze. If an owner's looking to massively upgrade the building and do a full replacement of the exterior facade, the VIG helps because it doesn't add additional dead load compared to a triple glazed unit in most markets. Plus, it's kind of opened the door for new construction based on energy codes. Because like when I, originally were thinking about VIG, I tended to think about it as either a reglaze or a replacement solution only. But it's really been opened up to all three. So reglaze, replacement, and new construction, depending on the need of the project and the energy codes they're trying to achieve.
I'll say one misconception I hear a lot is people throw around items like window manufacturers aren't prepared to integrate triple glazing into their systems. And I think it's false. I think it's very easily integratable. It's a little bit of engineering effort and some new dies. I spent a lot of time in the window replacement world, and what has me excited is there are implications with incorporating triple glazing, as you said, with weight, the existing structure, and the imposed loads that it can withstand. Also, from the installer standpoint, handling these big units with triple glaze units and all of a sudden cutting out a fraction of that weight. So I think in terms of in the reglaze or window replacement market, there are exceeding just past what center of glass U value you can achieve. There are a lot more implications in terms of what numbers you can all of a sudden achieve with different window types, and then what it really means for the surrounding or existing structure.
And Adrian, it also goes to the point you made earlier today about sustainability and embodied carbon. I mean, we're going to have thinner lights, we're going to have less weight, less structure, so your embodied carbon is going to go down. That's a popular topic. And then, as Leanne noted, on specifically a new build, when you'd go in there, or in years past, you go talk to an architect. What's your solar heat gain? What's the aesthetic you want? We down select all our great products to meet that need. Well, now you can design the facade first. Now you can start looking at your HVAC. Can we downsize that? Or if they're not comfortable, can we have a less of a load? So now you have operating cost savings. Energy is really expensive now. So this is another way that the glass and facade can start helping out that built environment.
All right. So final thoughts. I wanna leave it for Scott, Leanne, and then Jake. I'll give you two options to choose from. Either A, what has you most excited about this opportunity and what's to come in the future, or B, what you think the evolution is in terms of we have this product today, but this is where I see it going.
I'll go first. So to me, I'll get what gets excited is that what we worked with a window company where we put our product in there, and the total window was 10.8. Okay. And so when you take today an argon double silver low E, triple silver low E, and a 25 millimeter infill, your center glass 4.1, your total window is probably 3. Okay. And you do the same with a triple, your total window is probably going to be 5, maybe 5.5, right? Okay. So we've had people get 8, 9, 10, but when you start approaching that R10 total wall, then that's the big difference. Because back at BEC, I think it was way back in 2013, I gave a talk out there called The Battle for the Wall. Okay, and I said if the glass industry doesn't get its act together, they're going to be wanting or forcing a reduction in the window to wall ratio. Okay, which we're seeing. You're seeing more punched opening buildings instead of curtain wall because of the problem of meeting codes. So to me, it's kind of like I'm going back, 10 years, and, with this product properly designed with the frames, to maximize, frame U factor, condensation, and you got to make sure you got the right thicknesses for deflection and wind load. But, we can now finally start to increase that window to wall ratio without reducing, the energy and thermal performance of a building.
You're before your time.
No, I don't think that. I think it was just delirious or something. Delusional.
All right, Leanne, your turn.
Yeah, I think it's interesting Scott mentions the battle for the wall, because I actually was at a event this week where a facade consultant was standing up and advocating for shrinking the window to wall ratio. And no one wants to be in a concrete box. No one wants to be in a building where you're looking through a postage stamp or you're all fighting for a window to see outside. There's all kinds of health benefits proven that, access to natural lighting, daylighting, and more visual to the outside improves productivity and health and all of those components. So let's not shrink the window to wall. Let's figure out a better way to design so you have better performing products that hit the overall performance requirements you have and get us to net zero and reduce carbon. Like, why not look at it from a different perspective? I get excited about the product because of the overall performance and the impact to the holistic design. Plus, it's challenging me in areas that I haven't had to talk about before. Like, I never cared really about HVAC or decarbonization or embodied carbon. And so it's a whole different learning process for me, which I get excited about. I love a puzzle and I love putting things together. And I love the challenge of having conversations about glass in a very different perspective than I have in the past.
I like it. All right, Jake, most excited what you think is next in the industry or any misconceptions that you want to overcome?
Well, the most excited thing I've gone through is being enlightened on this product. So when you hear about VIG coming from the glass side, it's like, hey, this is going to fill a hole in niche, and really everybody's mind goes to historic renovations. And that seems like a slam dunk, and it really makes sense. And when you start looking at this built environment and the offices being vacant and people really want to turn those into multifamily, we have a solution there to have cost savings and improve the performance, lower operating costs. So that's exciting. And then seeing the other segment of new construction. So being able to keep it into the 8mm in thermal or go up to a 1-inch and add acoustic performance up to 39. I mean, I'm starting to talk comfort. I can talk aesthetic. I can talk operating costs. It's just been very fun. It's a fun ride to go down and talk to people all over the states, actually all over the country, on how this can impact them. So finding out down in Florida, down in Texas, there's a need for this. When you think about this, it's really like the thermos that you have, a Yeti type of technology in glass. And you think about that in a northern climate, that you have to have this down comforter on to walk outside. But now you can go down and say, hey, we can keep your cold air inside your building, and it becomes viable in regions I never thought possible a few months ago. So it gets me excited that I'm not really pigeonholed to one segment, that I can really go out there and help designers really design a building that they were said never could happen before. So that's the most exciting part about it.
I could feel the passion. All right, so I'm a LinkedIn guy, but I know everyone doesn't prefer that. So where can people go to learn more about LuxWall, or if you do or don't want to be contacted?
Well, you can go to luxwall.com. We have our website over there. It's a great way to go. I can send you over my contact information as well. We have some reps all across the country. We're here to help out. We have a lot of glass knowledge, as you heard from Scott, Leanne, myself. We have other counterparts that are from the glass industry. We have some people that have been doing glass before I was even born. So we have a lot of expertise here. While we may be new to the market with this technology, we are not new to glass. So I want people to realize and feel comfortable. We can go out there and help them with the aesthetics, the performance, and we have the backing and the brains behind it to make sure that we can have the help that you guys need to design those buildings.
And I will add, I'm sure you guys will say you will gladly welcome anybody to come do a facility tour.
Yeah.
Oh, most
100%.
definitely. Yep, we'll be getting that set up, and we'll get it really formalized so we can make sure it's going to be very beneficial when you see the technology, and the building is it really takes your breath away. It's quite fascinating, but we know time is money. So we're going to go out there and get it AIA accredited and make sure that we can get the most bang for the buck for the people coming out and taking a look at our facility.
Well, and I like to look at it as who wouldn't want bragging rights to say you did some of the first vacuum insulated jobs in the United States with the US manufacturer. So we're all excited about the opportunity to start, tackling jobs because the construction cycle's long and we've got a lot in there. But don't be shy, reach out, start asking questions, start trying to understand if it is viable for your project and how it's going to help impact it. And then again, just as people brag, they did the first, sputter coat low E job in the glass industry, people will get to say they did some of the first vacuum jobs as well.
Very cool. All right, Scott, Leigh, and Jake, thank you so much.
Thank you for having
Thank
us,
you.
Adrian.
Cheers.
Thanks for your time.